This is a bit of an advanced topic that can be skipped by a beginner. I shall discuss those cases where the function parameters are marked constant. This code shows a use of the construction keyword. This keyword is used to express the fact that a variable is read-only. It cannot be changed. This is a compiler error. A constant reference is a read-only reference. In this code, x is a non-constant int and y is a constant reference. X is changeable directly but not through y, because y is a constant. This compiles because x is a non-constant variable. This is a compiler error because y is a constant. This statement is a compiler error. How can anyone give an alias to a literal? Ref to a literal is impossible because this statement will cause a fallacy. This code doesn't produce any error. 9 is a literal constant and x is a constant reference to it. This code has no logical error. It cannot lead to any anomaly. But it still leaves a question unanswered. How is it possible to obtain an alias to a literal constant? The compiler has a trick here. It removes your code and replaces it with a more logical one. Compiler writes your code as follows. It creates a temporary object. Temporary objects are ad hoc objects. They are supposed to be constant so that your code logic remains unaffected. A constant parameter means that the function will not alter the argument. A constant parameter is a promise that the function won't change its argument. The use of constant with a value type parameter has no effect. You can easily see it why. In this code, y is a different variable that contains a copy of the argument's data. So any change to y would never have any effect on p, even if y is non-constant. This keyword is superfluous here. It can be safely removed. This code shows a constant reference type of parameter. This is a promise that the input argument won't be altered. A reference is an alias to the argument. Any change to the parameter affects the variable back home. So the use of a constant reference carries a sense here. I'll now write two programs that produce the same output. This program has a function with a reference type parameter. The function prints the square of the argument passed to it. The argument m is passed as a constant reference. M prints as 3 as m is passed as a read-only reference to the function. This is the same code with just one change. The function accepts its argument by value. The square of y is printed here. M is passed by value. It is copied into y. Here m prints as 3 because it hasn't been altered. Because it was copied and passed to the function. What is my conclusion? If your function doesn't change its parameter, pass it by constant reference. Don't pass by value. It will create an unnecessary copy of the whole data. Passing by a constant reference achieves the same objective, but at a lower cost. Literals can be passed directly as arguments for constant reference parameters. This code shows a function that has a constant reference parameter. We can directly pass a literal as an argument. It is possible because compiler can create a temporary here. The compiler could possibly be doing something like this. The compiler creates a constant temporary to pass a literal as an argument. In this tutorial we have learned about constant variables and constant references. It is not possible to create a non-constant reference to a constant variable. We also learned about temporaries and that they are constant. We also learned that passing an argument by constant reference could be efficient.